Hi everybody. I think everyone can hear me properly. Here we are going to present a group topic like the research topic on rapid prototyping. So what is rapid prototyping? Rapid prototyping can be called as a group of techniques which can be used to deliver quality products in more quicker way than conventional manufacturing process. So when you go back to the history of rapid prototyping, it emerged in 1980s, and Dr. Kodma, a Japanese scientist, he was the key person behind the technology, and he invented stereolithography (SLA), and which is now known by the apparatus name like stereolithographic apparatus or SLA. So that time, the conventional manufacturing process was not as quick as now, but scientists demanded a need for a new process which deliver more quality products but in a quicker way with more dimensional accuracy. And there came the invention of 3D printing, which is the basic principle behind all rapid prototyping techniques except high speed machining and high speed like rapid casting and molding process. So we are going to discuss in detail about 3D printing and other rapid prototyping techniques. Basically they are called additive manufacturing techniques. So I'm going to discuss and share my views on two major processes like 3D printing and stereolithography or SLA, otherwise known as stereolithographic apparatus process. 3D printing make use of the basic principle like make or print out the CAD file layer by layer, and which make it a part of additive manufacturing process. So SLA uses the same principle, but it uses a liquid resin. In 3D printing, we use a form of wire which can be plastic or a kind of fiber. This wire is rolled in rolls, or they are fed in the straight forms through the input, and they are melted in the tip of the nozzle, like the tip of the printer, and they are added layer by layer according to our CAD design. And hence, in fact, the material is printed upwards, like printed in the layer by layer, like a layer is added, and second layer is added on the top of that. So it's like a straightforward build-up process, other than conventional machining, which is like a destruction process. Like we are taking out material, and which led to a lot of scrap and a kind of waste. In 3D printing, you can consider it as a zero waste process. In SLA, it's a little bit different. So we upload the CAD file, and it is sliced. Basically, the CAD file is sliced in different layers, and the first layer is formed by laser curing. So there's a tank of raw material like a resin, and above the tank we are going to place the first layer, which is cured using the raw material, and the first layer is raised layer by layer, and all the layer which is forming beneath the first layer, they are cured using the laser treatment from the downside. So when we rise the whole thing up, and all the liquid resin forming in the shape of a required object or required CAD file, it is cured, which means condensed, and we get the final product when we rise the whole thing up. So SLA and 3D printing work on a kind of same principle but on different ways. We use different kind of raw material, we use different kind of curing process, and we use different kind of we can use this for different kind of applications. So every process including 3D printing, SLA, fuse, deposit and modeling, that's another kind of 3D printing technique, includes a kind of same pattern. We use a CAD file for that, and we're going to slice the CAD file. We're going to input the CAD file into a 3D printer or SLA apparatus or any kind of machine we are using. Then basically in the computer itself, slicing is done, and we're going to manufacture in an additive way, not in a subtractive way. That means conventional machining. So we can consider all the rapid prototyping process, most of all the rapid prototyping process, as a kind of zero waste process. And in addition to our secondary research, we also conducted a survey. Well, in the survey, we asked a couple of audience about how they evaluate the quality of the 3D printed products and how much they know about the 3D printed products. And we got best results. Most of the people know what is 3D printing, and they believe in the quality of 3D printing. And my friends, my teammates are going to take over the presentation from now. They are going to discuss about other processes and other steps involved in the 3D printing and a little bit of a survey result. Thank you.
Hi friends, I am JERIN. As my friend Harry discussed, there are two types of 3D printing technique, FDM and SLA. FDM means diffuse deposit modeling, in which the three-dimensional structures, prototypes, and products is constructed through a computer-aided design. And in stereolithography, the second method, which consists of the 3D printing technology used to create models, prototypes, patterns, and production parts using photochemical process in a layer by layer fashion. Then there are 5 steps in 3D prototyping process, which are CAD design, STL conversion, printing, prototype, then printing and testing. The first method, CAD design, in which the product is designed through a CAD software like Fusion, CATIA, ProE, etc. These are softwares which we can produce 3D models. Then the design is converted to an STL format, in which we can use in 3D printer for the printing. This can be done by the 3D printing the CAD software itself. Then the next step is printing. Like in an inkjet printer, we use ink. Here in 3D printing, we use polymers, thermoplastics, and kinds of resins, or even wooden substrates like some kind of polymers. We used that as a material for 3D printing. These filaments or feed wire is then added layer by layer to develop a 3D model, and this layer by layer process is which gave a base to additive manufacturing process. Then the next step is prototyping, testing. ASWIN will continue with the next 2 steps. Thank you.
Hi, my name is Ashwin, and I'll just continue with my presentation. As my friends discussed earlier, JERIN and Hari just introduced about the 3D printing techniques and 3D printing process, and JERIN just mentioned about the process that are involved and just the steps. I'll just continue with the steps. The fourth step is the prototype. The creative idea of ours is transformed into a product right now, and this product can be wait for the solidification. After the solidification has been done, we'll just take out the product and we'll just test it for the quality assurance. The next step of our process is the testing, that is for the quality assurance. After the quality assurance, we'll just check if the product needs any processing, like for the quality purposes, for the surface finish of the product, and remove some materials or metals that are just been extracted from the product. So after the post processing, the product is ready to be sold or ready to be taken. Like, we'll just get a well finished product with a good quality. And as discussed earlier by my friend Hari, we just conducted a survey that is good for our presentation and for the informal research report. From the survey, we got a good amount of, like, 80% of the people assured that they have a good amount of knowledge about this 3D printing process, and they told, like, most of the people agreed, like 80% to be precise. Next is about the 3D printing research data analysis. The research data analysis that we had gathered from among our friends and the classmates, we can assure like 80% of the people had agreed they have a good knowledge about this 3D printing and it has a good quality. They have agreed with us from the survey questions. And from this we can see, like, the 3D printing is a developing field. Like, we can, if we have much more researchers in this field, we can ensure that we can produce like complex parts and like many more advantages of this
3D printing technique can be taken into account if we have a good research or if we have good knowledge in this 3D printing techniques. And I thanks Chris for giving us a chance to present our presentation, even if it's to the online. That's what we can do in this pandemic situation. And yeah, that's it. Thank you for your time and consideration. Have a good day. Stay safe. Bye.